I'll describe this collection of apparatus. This box is a galvanometer. If current goes into the red terminal, I'll see a positive deflection on the screen, and if current goes into the black terminal, I'll see a negative deflection on the meter. The galvanometer is connected in series to one large coil, which is then connected in series to a smaller coil, and the return goes back to the galvanometer. So if current leaves this coil through this terminal, current would go into the red terminal, we would see a positive deflection. If current were to leave this terminal, it would then go into this coil, leave this, and go into the black terminal of the galvanometer. Now let's watch what happens when we change the magnetic flux going to inside of each coil. I'll start with one strong bar magnet. If I take the red end and push that in, you see there's a deflection. Holding it still, there's no deflection, and when I pull that red end out, there's a deflection in the opposite direction. What do you think happens if I put the white end in? Let's try it. The white end goes in, I get a positive deflection. The white end comes out, I get a negative deflection. Let's try the smaller coil. Notice that the deflection with the smaller coil is much smaller than the deflections with the larger coil. So red into the large coil, red into the small coil. Let's try that with a weaker magnet. So here's a weaker magnet. Put the weak magnet in, pull it out, put the weak magnet in, pull it out. Something else that's interesting is the speed with which I insert the magnet matters. If I take this magnet and shove it in quickly and pull it out quickly, I get a deflection that's very different than if I move it in and out slowly.